Hello, hello, hello! Ladies and gentlemen, welcome to Goto 10. How many have been here before? All of you. Fantastic. Warm welcome to all the 5-6 people that are sitting at home as well and watching on YouTube. Welcome to you as well. My name is Christopher. I just want to say 20 seconds about Goto 10. It's run by the Internet Foundation, comes from Stockholm. We have a location here in Linköping and we have a location in Malmö. Unfortunately, we are closing our location in Stockholm very soon, but you know, things happens. The Internet Foundation have run a lot of different businesses, and if you don't know it, go to the website and take a look at all the amazing job we are doing inside education and inside classic building for public people in Sweden. And of course, the Goto 10 place we are today is a place of meeting and sharing knowledge and skills, and this is the reason why we do Tech Tuesdays, which we do today, and there is one more coming up, but I will finish up with that one after the presentation today. My name is Chris. I'll be at the technical booth if something goes wrong, or if you have any questions. I just want to say, when we have live streaming, we need the microphone for the questions. So when Ig is presenting, he will repeat the questions, but in the little Q&A session afterwards, I will be running around with the microphone. No further ado, welcome to your work.
Thank you. Thank you very much. I think there's a problem with the TV. Is it turned off or should I reconnect?
Yes, just take it out.
No presentation is complete without technical problems in the beginning. I'll try it again. Yeah, okay, so my name is Sir Sjöblom, and I come from Sectra, and I thought I'd talk a bit about the transformation that we have seen in AI in the last few years. And before we begin, I'd like sort of a raise of hands. Who here has experience with AI? Okay, most of you. Those of you that didn't raise your hands, have you ever used Google Maps? Okay. So you have used AI. So depends on what you mean. But okay, I thought I'd start with sort of a quick history of AI. And the history of AI is quite old. It dates back to the 1950s, where the field was founded. And since then it has been ups and downs in sort of the adoption of AI or the trust in AI. And we've had these AI winters. And in the first AI winter, because when the field of AI was founded, it was thought that soon a machine would be able to do anything that a human can do. And then they realized that they had underestimated some problems, and nobody wanted to work in AI anymore. So that's sort of the first AI winter. Then in the 1980s, it was discovered how to train neural networks, a particular type of AI and machine learning. And then again, it was believed that soon we will have machines that can do anything that a human can do, very soon, only a matter of time. Then again, it was realized that there are some problems that we can't fix. And so we have the second AI winter. And then in the early 2010s, deep learning emerged on the scene, and that has been sort of the most recent technique that has driven development for the last few years. And again, we're in an era where we think that in just a few years we will be able to have a machine that can do anything that a human can do. I will come back to that. And I talk about AI and machine learning and deep learning. Perhaps you've heard these terms before. And sometimes they're used interchangeably. But I think this is a nice picture to have in your mind. Sort of that AI, artificial intelligence, is a large field with a number of different techniques. One of those techniques to solve artificial intelligence is machine learning, which is giving computers the ability to learn without being explicitly programmed. And within the machine learning, there is sort of a subfield or a specific technique called deep learning that accomplishes this learning task. And with deep learning, you typically have large or deep several layers neural network and try to get this neural network to learn some task. And what was sort of revolutionary with deep learning is that previously when you applied machine learning with neural networks, you typically had to engineer different features to put in as input to these models. But with deep learning, you could do end-to-end training. So you could sort of feed in raw data at one end and get the answer at the other end. You didn't have to do any manual fine-tuning. And as I said, if we are, again, we've seen these ups and downs in the adoption of AI and machine learning, and we are currently on sort of an upward trajectory. Shouldn't we expect sort of a new AI winter if we are to learn from our mistakes or learn from history? But I would say that there's a big difference between the current sort of development in AI and machine learning from before, and that is that these techniques actually work. And there are now several studies that show, even in my field, medical image diagnostics, that you can apply these machine learning algorithms to get really, really good results that are actually on par with a human doctor for some tasks. Yes, so we have this deep learning wave that started in the 2010s, and it was discovered that for these models, they work better and better the larger you make these models. So these are some model architectures from a number of years ago, but the trend is clear. The larger you make these models, the better they get at solving the task. There is, however, one problem with that. The larger you make a model, the more training data you need to sort of train these models to perform the task at a high accuracy. And for the field that I'm in, medical imaging diagnostics, it might be hard to get really good quality annotated data at these scales. But these deep learning models have sort of a trick up their sleeve. And that is that if you train one of these big neural networks, you can train them, for instance, to do face recognition, or train them on internet data of any images or any text or whatever you want. And then you can replace parts of this network. You can sort of rip out some of these layers, replace them with new layers, and retrain them to do, for instance, detect infections in chest X-rays. And this has been a very clear trend in the last, it has always been possible. It was realized that this was possible essentially at the beginning of deep learning, but in the last few years there's been a large trend in using this technique, which is called transfer learning. And that enables sort of the building of really, really large so-called foundation models. I don't know if you've heard that before, but you can build super large general models trained on internet data, and then they're made publicly available on sites like Hugging Face. So anybody can sort of download these base models, and then they can adapt just a few parts of this network with very little training data and get super accurate models. And the possibility to do this and the standardization of how these models are presented makes it so that more and more people actually can train new machine learning models on their problems. And that also means that AI is used in more and more areas. So I would say that one of the transformations, you might say, that has happened over the last few years is this availability of good transfer learning models or foundation models. And the other big transformation actually started or dates back to 2017 when Google released this paper called "Attention is All You Need." And in this paper, Google introduced a new type of neural network called transformer networks. Have you heard about transformer networks before? Some of you, perhaps? Well, it's a type of neural network that was originally designed to process text. And besides sort of being good at processing text, it was easy to parallelize this model. So you could train it more efficiently on large amounts of data. And even though this transformer model was developed to process text, it was later sort of discovered that you could adapt this model to process video or images or audio or any types of input data. And they were really good at that as well. And that also marks sort of a new paradigm in the machine learning world. And that is that previously you had sort of people working with text, they had their models, people working with images, they had their models, but now everybody was using these transformer models. So if an advancement was made within text, that could usually be translated into advancements in image processing as well. And this again sort of drives up the speed of development of new architectures and pushing the frontiers for what these models can do. But we're not done with transformers just yet, because as I said, these transformers were developed to process text, and they will sort of, one text processing thing you can do is build what is called a language model. And a language model is essentially one of these machine learning models that tries to predict the next word in a sentence. So you give it the beginning of the sentence, the cat, and then it produces a probability distribution over all the words that it could follow in this sentence. And that task wasn't that interesting in itself, but the folks at OpenAI, they discovered that you could sort of train one of these neural networks with the task of language modeling, and then you could switch out the task and ask it to do something else, sort of a bit like transfer learning. You train it for one thing and then you change the task and train it to do something else. And it turned out that it was better to do this other task if you had done this language modeling task before. And this is called generative pre-training. And I think you perhaps see where I'm going with this. You might have heard the term GPT before, and it essentially stands for Generative Pre-trained Transformer. So this is the basis of the ChatGPTs. It comes from this. And why language modeling is so interesting is that it is very easy to generate lots of training data for these models automatically, because you can take any corpus of text and you can just take the first part of a sentence or whatever you want, that you feel that in as your input, and then sort of the target variable that you're trying to predict is just the next word in the text. It's already there. So you don't need any human annotation of the training data. You can just automatically generate almost endless amounts of training data. So now we have sort of the important ingredients for the large transformation that we saw in 2022, 2023. We have transformer models that are easy to parallelize, so you can train them efficiently over huge amounts of compute. You have sort of a way to generate training data that is needed to be able to train these super large models. So of course that's what they did at OpenAI. They took huge amounts of training data, these new transformer models, and when they did that and trained them on this language modeling task, they discovered something unexpected. They discovered that these language models trained to predict the next word, they were what is called few-shot learners. They didn't expect that, but it turned out that was the case. And a few-shot learner, to explain what it is, we could look at the task of machine translation. So if I want to do machine translation, I want to translate from English to Swedish. Traditionally, I would gather a data set with paired sentences, English and Swedish translation. I would feed them into a neural network or something and train it to do this translation. And then hope that new sentences would be translated correctly. That is in difference to these language models. They are trained on data sets that look like this, just the beginning of the sentence and the next word that followed in that sentence. But is it trained perhaps on data from multiple different languages? So, even though it's trained on this type of data, it turned out that you could prompt the model. You could sort of give it instructions, not only the sentence to translate, but also the instruction that it should do translation. So you could say, translate from English to Swedish, give it an English sentence, and it output the Swedish translation. Not at all trained to do this, it just turned out that it could do this. And since it hasn't been trained particularly on data in English to Swedish translation, you could ask it to do a number of different things, like translate to French, or reverse a sentence, or do other manipulations of the text. And this is sort of the basis for the ChatGPT that we see today. And this again changes sort of the paradigm, or lowers the barriers for applying AI and machine learning. Because now you don't need any technical expertise, you don't need to know how to program to apply these models. And essentially for each prompt, for each instruction that you feed in, you get a new machine learning model. It's the same base model, but it performs the task, it performs a new task. So now anybody can sort of be a machine learning engineer and design a new machine learning model and apply it to a certain task, essentially. And that is, of course, what we see. We see these models being applied almost everywhere now. And these models, they are really good. There are, of course, corner cases, but they tried these GPT models, GPT-4. They gave it a number of different college exams, American college exams, and it scored really well in almost all of them, even though it wasn't trained to do so. And it's not only sort of memorizing training data, because you could also ask it to perform a number of different model tasks that it couldn't possibly have seen in its training data. Yeah, like writing a proof that there are infinitely many primes with every line that rhymes, and then it can do that. Okay, so that's sort of the backstory. There is the technical components that we need for this transformation that we have seen, but how can we apply it in our life? How have we applied it at Sectra and in medical imaging? So one thing that we have tried, this is a screenshot from one of our applications, products, our image display system. It is used to look at radiological images and perform diagnosis. And you have a number of different tools available. You can sort of change image settings, rotate the images, annotate it, do a number of different things that the radiologist needs. But we have a lot of features in this product. So many that most of our users don't actually know which features exist. And we can see that when they use our product, that they don't use the features we have developed to perform a certain task. So what you can do with these models is you can take the user manual. This is an excerpt from a user manual for this system, just a short snippet of text describing something, how to accomplish a certain task. You can feed this entire user manual into one of these LLMs, and then you can have the user ask questions or say, I want to do this in your system. And the LLM can sort of look in the manual and sort of connect different pieces of information and produce, you should do this, you should click on these buttons or open the options, etc. to do this. This slide is from about a year ago, and when I wrote this presentation, so this part of the presentation a year ago, this was cool stuff. Now everybody has seen probably something like this. It is part of a lot of different applications, but a year ago this was novel. Yeah. But you can also do other things. You can go one step further, and you can give these language models, the GPT models are called large language models, LLMs for short. And you can give these LLMs access to different tools. So I'll explain sort of how you can use tools. If you want an LLM to build your house, it will have problems doing that because it's a machine learning algorithm. It can't build anything. But you can sort of give it a description of the tools that you have available. So you can say, I have all of these tools and what they do. And now the LLM can sort of reason about how to use these tools to perform a plan for how to build a house, for instance. And then it just outputs, use these tools in this order, you will get your house. So simplified problem description, but you get the idea. We can apply the same sort of idea within our application. So this is the same excerpt from the manual that I showed you before, but I've added some text, sort of added, these are the tools that are available in our application. We typically have those available in our source code, so we can sort of extract them automatically and just feed them to the model. And now when I ask a question, sort of the same question as before, I want to look at a larger image and I want to view patient information, it can just output which commands should be executed. And this list is easy to sort of feed back into our application to a command executor. So these commands are then executed automatically within the application. So instead of sort of being given a description, you should do this, we can sort of make it happen automatically. So you can just talk to the model and it performs stuff in the application. And I did this. Of course, I had to try it. So this is a really new prototype that I built just a few weeks ago, where I connected 3 different machine learning models with our application. So in this prototype, you also can sort of press record, and you can talk to the model. So you just speak directly, ask it, I want to do this, and then I have one machine learning model that takes this spoken audio and translates it into text, the transcription. I take this transcription and I feed it into one of these planning LLMs. So I've prompted an LLM to say, you should plan out how to do stuff in this application. Here's the manual, here are the commands. It can then start issuing commands. Those commands are executed, and when it comes to a certain type of command, in this case a segmentation command, it should segment something, then it also constructs a new prompt for the 3rd machine learning model, which is also promptable. So in this case it realized that I would like to highlight the liver. Okay, so it realized this is a CT exam and I should get the liver. So it puts that into the segmentation model, which is also promptable. So the segmentation model realizes that, liver, that must be this large structure over here. And then it segments that and feeds everything back. So I think that we will see a lot more of these types of applications of machine learning. I think that in conjunction with mouse and keyboard, which are normal input devices, I think we will see sort of voice and commands being issued as well. We at Sectra, of course, not the only ones that have applied machine learning to medical imaging. Google actually released this model. It's a couple of years ago now, but called MedPalm-M. And this model is trained not only to look at just images or just text, it is trained to sort of absorb both images, text, genomics data, lab results, anything. You can feed everything into this model, and then you can get it, for instance, to write a radiology report. So in this case, you just give the model the indication and the radiology image, and then it outputs this sort of radiology report that is on top. And below is sort of the reference report that is written by a radiologist. I think this is sort of a cherry-picked example from what I've seen, but nonetheless it's quite impressive to be able to do this. And the future might lie in this direction, perhaps not replacing radiologists altogether in one go, but we will for sure see more automation within this field. Another trend, a very recent trend, is also to use agentic workflows with these LLMs, and this has also been tried in the medical domain. In agentic workflows, you have several different AI bots or LLMs that are prompted in particular ways to perform a more narrow task, and then they collaborate within themselves. And one of the areas this has been tried is in virtual MDTs. An MDT is a multidisciplinary team meeting, and you typically have a number of different specialities like pathologists, radiologists, oncologists that get together and discuss certain complex cases. So what has been tried is to essentially prompt different LLMs to take on the role of a radiologist, a pathologist, and an oncologist. And you give them sort of access to all the literature and all the population statistics, etc. And then you can feed in all the data you know about the current patient, the lab results, the genomics data from any sequencing, radiology images, pathology images, and then you can sort of have this virtual multidisciplinary team meeting and ask the different models different questions. And this is only sort of very much on the prototype stage, but if this works, it will revolutionize sort of the quality of care that can be given. I thought I'd show one last example within medicine, and this is, I think it's cool, but it's also perhaps a bit scary. See what you think. So in this example, they had a number of different subjects, people that were shown images of different objects. And they were shown these images while they were in an MRI scanner, so they could record their brain activations with an fMRI. So the people were in the MRI machine, they were shown images, and then they measured the brain activation, which is seen below here. And then they could take this brain activation and feed it into image generative models. And these images are in pairs. So on the left you see the image that was shown to the person, and the image on the right is reconstructed from only the brain activation of these subjects. And I mean, of course, they're not identical, but they're close enough. I mean, essentially, you could read the mind of someone that was in this MRI scanner. So, cool, but perhaps a bit scary as well. I don't know. To sort of summarize, I think that the prediction that Andrew Ng made a couple of years ago, he's a famous AI researcher, that AI is the new electricity, we are sort of on the cusp of that being true. We see AI sort of being used in almost all areas in society today, and that will probably only continue, for better or worse. And I asked previously if you had used AI. A lot of you raised your hands, and perhaps you've used these ChatGPT models. You might be impressed with some features and not that impressed with other features. That is usually the case. But we should also remember that we as humans usually have a distorted view of intelligence. We sort of sit on top of the intelligence ladder and look down on everything else. So when we see that an AI goes from having ant-like intelligence to a bird-like intelligence, it seems like a super small step. So it will never be as smart as human. It can't be. I mean, it's only down there. But if we rescale the intelligence axis to something that is probably more realistic, we see that the jump from ant to bird is a giant step forwards. And the difference between a dumb human and Einstein is very, very, very tiny on these scales. So perhaps we will get an AI that is as smart as human. I don't know, nobody knows. But we shouldn't underestimate sort of the progress we have made. This has of course prompted some people to have concerns. and you might have heard about this in the news. This is from about more than a year ago. You might have heard Max Tegmark, the Swede, in his Sommarprat, where he talked about this. So some people are concerned, and it's hard to say if you should be concerned. Some of them are. I mean, there are now no slouches on this list. The first name here, perhaps you remember even better now. It's Geoffrey Hinton, the latest Nobel Prize laureate in physics. So some people are afraid, but other, also very prominent AI researchers, believe that these models, they are nothing more than useful writing aids. So if that's true, I don't know, but I think that you all and me will have to deal with these models being available almost everywhere in the future. And with that, I conclude my presentation and open up for questions. Do we have any questions? Over there.
What's on the roadmap for sector in terms of AI?
I would say that using AI more internally, not only to sort of develop our products, of course, everybody does that, but also more in line with what I showed with this speech integration, etc., to be able to integrate a number of different models and making them available to our users. That I think would be most closely in our roadmap. There will of course be, we do a number of different research projects where we try to apply machine learning models to, for instance, structured data. A lot of the data in medicine today is unstructured, and to automatically apply a structure to it could help more sort of conventional data processing later on in the pipeline. That is also a sort of a hot topic that we look a lot into. More questions?
First of all, interesting lecture. You say a lot of training data. So first of all, how do you collect this data? The second, if data increases, then you have to develop your mathematical model as well, or on the other hand, statistical models. So how is going, statistical model development hand to hand with the training data?
Yeah. So actually, quite recently, it's in sort of the news. Is that the latest models, the expected GPT-5, etc., they start to see diminishing returns on sort of expanding the data volume. They seem to have used most of the internet by now. But I mean, that's most of the textual data on the internet. I mean, there is a lot of data in video, YouTube, Instagram, whatever, that hasn't been tapped. So I think there is still there is room to improve these models by just making them bigger for some time yet. But for sure, we should perhaps find other ways to be able to utilize even more data or find more data. I mean, we as humans typically learn from interacting with the world, and we we produce lots and lots of training data through our eyes all the time. So some researchers, John LeCun is one of them, believe that that is the way forward. We need sort of models that can interact with the world and collect training data by themselves. That's the only way forward. But as I mentioned, the good thing is that with the models we have today, we can adapt them to sort of more narrow tasks with very little training data. And that is an untapped category, because we don't all have to train the next sort of human-like intelligence. There might be a number of different areas where we can apply a dumber model that is good at a specific task instead. And that you can do with a lot less training data. I think we had a question over here.
Yes, multidisciplinary team is now routine within the hospital here. But with this method, could it be used on a global scale so we could have contacts, so to say, with very good hospitals all around the world?
Yes. I mean, that is actually a discussion, AI aside, that is being discussed. Sort of, we see, or the doctors, the need for higher and higher specialization, sort of. So the MDT going from just being hospital connected, or perhaps even nationally, going even internationally. So, and with these models, perhaps because they can work autonomously, they can sort of act like an international specialist, because they can have access to all of the literature, and it's no problem for one of these models to read 2,000 books in a couple of seconds, something that is hard for a human to do, and to retain all that data, but they can. So that is one aspect. I mean, they're not as good as we at reasoning, but they're really, really good at sort of parsing through huge amounts of data. So I think there will be, these could open up for much better quality of care, yes.
Thank you for the interesting seminar. So my question is, you said you have this Gen AI tool from Sectra, and also Google have their tool site for the medical use cases.
Yes.
So how do you compare or differentiate your tools with theirs?
Yeah, okay. So the model from Google, the paper is out. That is a prototype. They just tried doing this multimodal, and as I said, the example is from their paper. It's probably cherry-picked. I would assume that it doesn't perform that well on any case. And that is typically what we see with these models. They are really good, but they do make mistakes. And I would say that from Sectra's point of view, we're very much focused on, we can't sort of just let this model go wild. So building sort of guardrails and building infrastructure and interaction design to using these models, that's sort of where we differentiate ourselves. Being more practical in how you actually can use these models to get good medical outcomes. So Google was most interested in, is it possible? It seems to be in certain cases. We as a company are more interested in, is this useful? And in what areas is it useful? Can we tailor a model more narrowly to perform this task because it's a useful task to perform? So I would say that differs a bit, that the Google model is more on sort of this science for the sake of science, whereas we try to be more pragmatic and applying these to get good outcomes.
Okay, thank you.
Thank you for your talk. I have a question which could be open, but I was thinking, do you think that the future is going to be a multi-agent world between these AIs, or is it going to be one centralized AI which everything is connected to?
It's super hard to say, of course, what the future holds. I don't know, but from what I can see, in part because it seems that these models are beginning to saturate. They don't become better with more data at the same pace they did before. So one sort of solution to that is to not try to have a model that knows everything. And that would sort of speak to this agentic world, where you have models that are good, but they are more narrow. And to solve a more complicated task, they utilize different types of AI agents. I mean, they could be the same model sort of at the base, but they're sort of tilted to perform different functions. That seems to be, at least like last month, 2 months, the trend that we see. I mean, everything moves so fast in this area. So, I mean, I couldn't say where we will be in a year if we come back here and have this. It could be a completely new paradigm that we see then. So, but currently my bet would be on an agentic world where you have smaller models or more focused models that work together and are being orchestrated, perhaps by a human, perhaps by another AI. I don't know. More questions?
More questions? No, but Eric, you will stay around?
Yeah,
and
sure.
Because I always know there's somebody there's a little shy and don't want to raise their voice in the audience, so you can come up and speak with Eric. Thank you very much. I will big applause for today. Thank you. And I think you put the nail in the coffin, as you so to speak, because last Friday we had another AI event right here in Goto 10, and what we talked about then was that we always say AI assistant, and that is so stupid, because there are professors and researchers and doctors and anything. I think we need to put that out to the world from Linköping, that it's not AI assistants anymore, it's really, really good knowledge in these systems. So thank you very much for today. I just want to say to the audience, next Tech Tuesday is the 10th of December, and it's Combitech coming with new science. So be back and we'll see you then. Thank you very much for today, and thank you to all the watching out there in the stream. Thank you.